worksheet 12C. This should be the first worksheet we do before we go back to 12A and B. The stress block shown represent the stresses on the two orthogonal planes through a point in a structural member. Determine the normal and shear stresses on the plane AA through the point. So as you can see, given in this case, the given sigma x, sigma y, tau xy, and want to define what is sigma x apostrophe sigma tau xy apostrophe. So with that, with that stress block, what is given, and we want to put it out. So as you can see, with that given here, we have sigma x, and as you can see for the sigma x here, it in compression, they make the block, the yellow block, compress. So that's why it's negative. So it will be 114. So nothing new so far, psi. And then the sigma y go out of the plane. So it in tension. So you have sigma y equal to positive, just here, 1000 psi. And the tau xy, and as you can see, you only need, they are the same on the plane in terms of the magnitude, but to use the analytical method, the one that we use, the equation we just talking about, you only need to see what is the direction of the shear stress tau xy on the positive x plane. And the positive x planes, as you can see by definition, that is the plane, the vertical plane on the right. Remember, the plane is denoted by the axis perpendicular to it, not parallel. So that is the only see at the positive x plane here. What is the tau behavior? So that is the positive. Let's write down positive x planes. We only need to x plane. Make sense? And when you see that, you see the tau on the positive x plane. Yes, tau xy going down, opposite to the sigma y, the y, positive y, which is going up. So it will be negative. So here it's negative 500 psi. 100 psi, and tau xy, I mentioned earlier, the x is stand for the plane and y stand for direction of the tau. So we can have right here. So x stand for the plane. So the tau on the x plane. And y it stands for the direction of the tau. Directions in y direction, because you can, if it's in 3D, you have z direction, then you have tau xy and tau xz. If you say tau x, okay, so it only like sigma x, but tau x is which direction? It on that plane, yes, but it can be in y or z, so that we need to have two script to define the tau. Why only one script to define the normal stress? Because if it sigma x on the x direction or perpendicular to that positive x plane, then it already completely define that normal stress. So, and to find out the sigma x apostrophe for the AA plane as shown, we need to find out the theta. So how to find out theta? Get down here. How to find angle theta? And I make it very slow in here so that you can see it, how to define all of that information. So that by definition, the angle, I write down here as I stated earlier, but now let's write down so that you can, the angle theta E define what? What the definition of theta? As the angle between x plane, in this case I show up there the positive x plane in there. So how? Remember what is the x plane? I just write down here the vertical plane that called x plane. And why is that? If you recall the vertical plane is denoted by the axis perpendicular to it. So the vertical, the plane is defined by the axis perpendicular to it. Perpendicular to the plane, right? To it. Keep that in mind. So from that you see the angle theta is defined as the angle between the x plane, you know already what is x plane, and plane AA. Plane AA that defined in the problem. And when it's positive or negative, so it with the theta, let's put it down here, period, no comma, and the theta is considered positive when counterclockwise from the original vertical x plane, and of course the other way, negative when clockwise. Very confused when we just say that here and something later on the Morse circle with the sign convention for the shear stress a little bit different. But then keep in mind for the analytical method, and the theta is always defined by the angle between the x plane, the original x plane, with the plane AA. What is x plane? Just mentioned there. And consider positive when that angle is counterclockwise, and negative when it clockwise. So from that, how can we find out the angle theta? So if I redraw the block here so that you can see to be able to find out the block to theta. So in this case, I just redraw the yellow block, here. Let's do that here. Just make a block here. Then the AA, as you can see there, the AA is from that angle. Okay, so from that AA here, AA, then you have that angle theta by definition from the x plane, and as you can see, x plane is vertical, so the angle theta is from x plane to that AA, and in this case, as you can see, is counterclockwise. Oh, it's clockwise. Sorry, it's clockwise. You see that there, right? So it's clockwise. So that is the angle theta that we are talking about. In this case, clockwise, and clockwise, then negative. And we already have slope angle here. Is they give us 4 and 3. So from that we can have theta with the similar triangles, as you can see here, that angle here also theta the same angle theta in there, so that you can see the tangent of that theta, tangent of theta is equal to opposite adjacent 4/3. So from that we can have theta inverse of that tangent 53.1 degree, and in this case, like I say, count clockwise. When it's clockwise, by definition there, it's negative. So you have, when apply in the equation, it should be negative 53.1 degrees, because that is clockwise. Or the other way that you define that is from the plane, x plane, right? But like I say, the plane is defined by the axis perpendicular to it. So you can do the other way, or very simple there. You have the x axis you have here from that plane, from that we have x axis here, horizontal x axis, and then the AA, the plane AA, which we already have, and slope of that plane again is 4/3. Then with that plane, the plane is defined by the axis perpendicular to it. So what does that mean? We will have the plane for AA will define by the axis perpendicular to it, so that it will be perpendicular to that way defined, and that it basically it x apostrophe, because that plane AA becomes the AA. We can say that is the x apostrophe plane, because that define the plane defined by the axis perpendicular to the plane. Okay, so from that we can find out, instead of find out that angle in that way from the plane, we can find out with the axis, and from the original x-axis to this axis, that also the theta, and as you can see here, if that 4/3, then the vertical we just flip, here with that angle, so flip, so that will become 3 and 4, and you learn in the statics. And from that angle theta, as you can see, it also same as this angle, so from that here you can have the theta, tangent theta, equal to, of course, opposite over adjacent, and we also have theta equal to 53.1, and as you can see, clockwise from the original axis to the new axis x apostrophe, or only on way from the original plane to the new plane, as you can see there. So either way, so in this case, as you can see, clockwise, and from that we can have equal to, when it clockwise, so it's negative 53.1 degree. So that is very important. Let's stop here just to have that general information, how to find out the theta, how to determine the sigma x, sigma y, tau xy before we apply in the equation. So it just not pick the number magnitude, we need to consider the sign. And with that, we continue to the next to apply the equation for this problem in the next part of the video.